Hey everyone, welcome to this new IEN Talk. Today we will have Evaldas Drasutis. As you guys know, he's leading the IOTA Smart Contracts development team. Evaldas and I met here in Buenos Aires, I think that 1 year ago in the pre-COVID era. He loves tango, so he likes to visit Buenos Aires. And he had the opportunity to assist to some of the IOTA Argentina community cluster meetups that we did back then. So as usual, we will be having him with his presentation. And once he finishes, we will be able to have a little Q&A round. So you guys can just type in your questions on the YouTube chat. And I'm going to be reading those questions later. So that's it on my end. I'm just going to welcome Evaldas. Hey, Evaldas.
Hello, Daniel. Thank you.
So whenever you want, just go ahead, man. All yours.
Okay. So hello, everyone. I hope you see and hear me. Or no, I will talk today about the IOTA Smart Contracts. So actually, it's been a while we didn't talk about that, and in general, we didn't talk much about that because we wanted to have something something working, something to talk about, concrete. So this is the first time we are talking now, and the title shows it that we are talking in the context of our recent pre-alpha release, IOTA Smart Contract Protocol. And I will go through through general stuff, and also I will introduce and talk about the details, the concepts behind that, and will hopefully show some demo, at least something which is live on the network. So in general, we are talking with guys, with teammates, that it's very simple. Normally, you formulate something that you are talking about, let's say, distributed ledger or something, and it's everyone knows what is it, and it's simple 2 words and so on. But when you start talking, it becomes completely complicated, very much complicated stuff behind that. And the same feeling is always when everybody knows what is smart contracts, because smart contracts are supposed to be something which is everybody understands what is that. And then when we go a little bit into detail, then it's becoming more complicated to explain what is all about. Because so in general, first I will put everything into perspective from the IOTA, and we're looking into this smart contract. So basically what we have a ledger and distributed ledger technology. Everybody knows what it is, but then why would we talking, and why would there is so much activity around the distributed ledgers all around the world? So we have a special value proposition here, which is that we have permissionless. That's fine. Scalable. This is very important. Minorless and feeless ledger, IOTA Tango. And normally this ledger is operated from outside of the ledger. Means that the state of the ledger is changed by something which we call clients or applications or apps. Yeah. And we want, just like any other, many of them are examples of the distributed ledgers, we want to have a smart contract. The distributed ledger automation. We want on-ledger automation. We want to see ledger as a programmable state machine, which we ask to do them something, which means that we request them for services, and it updates its state, actually the ledger state, according to some algorithm. That's what means it's programmable. So far, nothing new. And actually, it is nothing new about the, and that's what I want to say, to putting everything into the general perspective about that, that it's we're talking about the what could be called classical smart contracts, function-wise at least. So what we're aiming at it's a distributed programs, which sometimes we call trustless, with all necessary features, normal features and properties of the smart contracts. These are universal to build apps, which also means the same thing about that it's a universal Turing complete machine. It automates the ledger operations on ledger by locking and moving under some algorithm tokens which are on ledger. But we are looking at it as a just distributed as the ledger itself, which means that we should not trust, for example, someone who processes the program itself. So this is a distributed consensus, and we of course we want to have something like on contract ledgers like ERC20 or something, which is kind of a direct implication from what was told above. We also want that all these smart contracts communicate between themselves on a ledger, trustless way, meaning that they don't know each other. And what is so when there is nothing fancy we want, yes, but what we want actually with IOTA smart contracts is that we want to preserve the main virtues, main properties of IOTA Tangle, which is a scalability, which is zero fees, and what is important, especially to smart contracts, is low operational costs, in cost per transaction. So this is a general perspective of what we're talking about, and it's been a while. We started that, meaning it's about a year ago, designing the main features, main solutions and concepts, drafting those solutions and prototyping them. I think if some elements even went through something like 3 or 4 versions, internal and POCs, until after 1 year, actually, we came to some moment which we just announced that it's our pre-alpha meaning that it's working. Release of the Wasp node. There is a software which runs the protocol of the smart contracts. It's called Wasp. And now we can say that essentially, in main features, the design of the IOTA smart contracts is essentially complete. It is the core protocol. We do not talking about extensions because the protocol is pretty much open to many extensions, and on purpose. We didn't go too far with that. We went at the core protocol of which is able to run and handle IOTA smart contracts. So we have a node which you can find in the GitHub repository. I will later show the link, but of course you can find from our blog post. We implemented something 3, actually 4 smart contracts, and even more of them, but only 3 of them where we deployed live, just to demonstrate what are concepts, and we will go through it today. It's simple, but they are smart contracts. They are realistic smart contracts. So we developed the wallet for that, also for demo mostly, but still the operation is real, and the tokens it manipulates all this also real, assuming that the pollen is real. I mean, the pollen is not a main net, but it's on the pollen network, on the experimental Gossamer network. And we have Go libraries what is not ready at this point in time. So we didn't manage now to include the Rust and virtual machine stuff into this release, but we will do it soon, hopefully. This is our priority number one, and we will be developing it. However, of course, we can run smart contracts like as hard coded into the Wasp itself. It's not very typical, but for testing, it's very, very nice. So it's not, and actually, we have some plans, a lot of plans, and we are actively investigating and trying to plan future developments of the protocol, and it very much depends on the how the Gossamer goes, and the postcode decide IOTA protocol how it goes, and maybe even we're talking about the Hornet and the Chrysalis UTXO version, which we will see how it will go. At the moment, I'm not want to go into detail because it's pretty much ongoing discussion. So this is I finish with a general perspective. If you will have questions regarding that, then maybe we can do it afterwards. What I want to do now is, when I preparing for this presentation, I was thinking that maybe it's a little bit too boring. Reading all these slides and bullet points and so on. So I decided that maybe I will have this as a background, and I will just show those main concepts of our smart contracts right on the demo dashboards of the which we are deployed on the Poland network, actually, or next or on top on the Poland network. So, first of all, I will explain about Wasp nodes. Our first intention was to make a Wasp as a, and not Wasp, but the entity, the software piece of the software which runs the protocol as a part of the Gossamer, as a plugin. But actually, it doesn't fit there too well because it's big itself. It's about 35,000 of lines at the moment, and also it's still the, as you know from our introductions, the design is a level 2, and it very well fits into the concept of the network of Wasp nodes, which is running on top of the Gossamer layer of nodes. So we have this structure, like Gossamer running the Tangle ledger. Currently, it's a Poland network. It's experimental Poland network. I think it's several hundred even nodes now have. It's running and it's developing. It's for testing, for all kinds of experiments and so on. And we deployed. The smart contracts are run on top of that by the network of Wasp nodes. Each Wasp node is a node which is capable of running many smart contracts in committees, but each of them can run many of them. And the Wasps are communicating on their own network. I mean, directly connected with each other on peering. That's why layer 2, and then they submit all the data, not all the data, but actually I will explain later how it works to the Tangle. So this is how it looks like. The Wasp node. Actually the Wasp node is pretty lightweight. Node and I think even small devices, right? Raspberry Pi or something can run them easily. Now, the next concept which I want to discuss. It's committees, and also the purpose of the actually when we're talking about the smart contracts are programmed, but not just programmed. They are run in the distributed processor, which means that the many processors, they are running that program under consensus, meaning that you only have valid result out of the distributed processor when nodes come to agreement what the result is. So, for example, for so-called level 1 or like Ethereum contracts, it's the whole network is a processor, and the whole network has to come to the consensus. Here we have, due to many reasons, talking about the flexibility, cost, and special features of the Tangle, we have fixed committees are running the smart contracts. So fixed committees mean that it is a distributed structure. It means it's a fault tolerant structure, and fault tolerant means that you can kill some of those nodes and it's still running, any of them. Yeah? So the committee is the idea of the committee is that you have some committee size. I mean, n nodes, 20, 50, 100 maybe, and you have a so-called quorum factor. So it means that some T, here T, normally it's more than 50% and maybe sometimes it's very often it's 2/3 something. But anyway, the quorum means that at least T nodes have to come to consensus on inputs to the program and results, obviously. So what the committees, it means that if T committees, and this T is more than half, like 51% or something, so the rest of 49, let's say 49% of nodes can be malicious, can be down, or doing something Byzantine, some dishonest things, but they're not doesn't matter, because when the quorum comes to the consensus, it's all set. It's all known. And in IOTA Smart Contract, so I will show you the let's say this is our dashboard for demo smart contracts. As I hope you see, I will use it more later to explain main elements of all that. But if you look, for example, into this smart contract, open smart contract details, you see committee nodes, which actually here in this case, this smart contract, which is called Donate with Feedback, it's run by 5 nodes. It's not shown here, but the quorum factor for it is 3, meaning that you can kill 2 of those nodes, any 2, and it will still running. Will be still running. So there are more. These are all of them. So others, for example, this one, token registry, is deployed on 10 nodes, and the fair auction is deployed on I guess 15 nodes. 15 nodes with quorum factor of, if I remember correctly, is something like 8. So it means that only 8 of them needed to function correctly and properly to produce for the smart contract to function correctly. So this is a list. It's what we're not supposed to do in normal situation. We normally want to hide all those committee nodes, so-called, in order to avoid all kind of distributed denial of service attacks or something like that. here we just list for demo purposes. So don't see it as a normal thing. Many things here in all these demos are not very much normal and not very secure. So please do not attack, at least now. But anyway, so we show that it's running on the distributed network of nodes. And believe me, it's really, you kill some of them and it's still running, any of them. Then we can boot them and kill another part and it's still running. So each committee owns a distributed set of private keys, each node. Yes. And this is another question, how we do this. This is called distributed key generation process. I don't want to go now into details because it's pretty much complicated stuff. But just finishing the topic about the committees, because it's very often the question is, and who selects those committees? Because committees, what makes IOTA Smart Contracts, at least this level of the protocol, pretty much different from the when you have all network the validators, so-called validators or of the smart contracts, run the smart contract. So basically, the structure of this makes the committees a permission structure. It's don't want to go into details, but anyway, someone has to decide, or maybe they have to decide between themselves. They want to come into this committee to run the smart contract. So for many corporate use cases, especially where let's say Hyperledger or Corda or some other are used, Hyperledger Fabric, it's absolutely the case. You have some committed parties like consortium, and they run the distributed system, which actually is, I mean, it's trustless too, because the consortium members can have different interests. We leave this part about how the committees are selected outside of the protocol, also following the very much ideas from IOTA, like freedom and openness. We imagine that it's sometimes could be formed by consortiums, sometimes it could be by the open market for committees, and we want to be open here and give opportunities to grow systems on top of that. So that's a question shortly about the committee. Now, I will explain more technical concepts of IOTA, just looking into this. So the smart contract is something like entity or software agent on the Tangle. And first of all, what we want to do is to address it somehow, identify it somehow. So there are two concepts, address and color. And if we, for example, open the smart contract details here in the donated feedback, we see this part here is smart contract address. What is it? The smart contract address is an address on the Tangle, on the actually Goshimer value Tangle. So if I open here Goshimer dashboard, I will see the all information about that address, just like current mainnet. It's different. It's UTXO with a balance, with everything, and so on. So we have address, and it's just a normal address. You can send tokens to that address, just to any other address. Of course, it's not it's a little bit not normal, because it's a little bit different, the cryptographical scheme behind it, so-called BLS address. And what is behind it? It is controlled, this address, by the actually distributed keys, so-called threshold signature. You need T out of N keys at least to produce a real signature and to move the valid signature and to move the tokens from this address. Then what else do we have? Second very important concept of this smart contract is a color contract. You can see it here. The color of the donated feedback of this instance of the smart contract is color. And what is color? Maybe I will talk a little bit later more in detail about, but what we are implementing in the Goshimer, it's a colored token, so-called. They are known by other names too, like tokenized assets or some other names, tagged tokens or whatever. But these are basically, it's IOTAs who has assigned a tag, a hash of the transaction, of its origin transaction, minting transaction, to the IOTA token. And in this case, in the smart contracts, without going too deep into details, we have one non-fungible token, which means the token with this color is the only on the ledger and will be the only ever, if not destroyed, but the second one will never appear. And this color is another identifier of the smart contract. Actually, if you look into the balance of that address, this is a balance of the smart contract address. It contains this number of IOTAs. That number of IOTAs we are donated by people. The biggest one is 128 IOTAs, someone donated. And you see there's one colored token, exactly one of it in the balance. So this colored token is the token of this color. And this is a token which is always lives in the balance of the smart contract. And this is how we achieve the global consensus on the state of the smart contract. It means that the smart contract, whenever it's changing its state, it will never fork, because if only one state, there is only one token, it cannot split in two. So this is an example of how underlying color tokens are used. This is we use it in other parts too. And I remember Hans called it very well, that it's actually a way of coming to consensus on data. So IOTA smart contracts, it's exactly the example how we do this. We are having consensus on data, which is specifically the state of the smart contract, and it's the only one, it cannot be forked. It's objective, so to say. Well, so I introduce here the two, address and color. Address actually it hides, it's more useful, but we more, how to say, common. But we are developing now currently, there are many ideas actually to use color as a main identifier of the smart contract. But it's another talk. And normally you do sending the request to the address, to some address as a target. In future, we have plans to send requests to color. This will be another development of the smart contract protocol and of the ledger, the UTXO ledger. So shortly about yes, how do we have? So when you look into this, let's say, for example, we can go into the fair auction. Yeah, we can go and we have balance of 22 IOTAs, and we have actually 3 color tokens, each of them with one token, right? One of them is, as you know, it says color of, yes, this one, yes, it's of color, and 2 others, it's someone is selling the token of this color. It's here, the token in this balance, and this is another token which is actually related to the backlog processing. I won't go in detail here that, but interestingly, it's someone is selling this. Someone created this auction a week ago almost. There's 1 day more left of this, and they want to convince us that Bill Gates wants to microchip. I don't know. The problem with these ledgers immutable, because when you have spam, you cannot just erase it because it's mutable. So you have to delete it all. I mean, to do to the whole smart contract, which we can do. Stop all 15 nodes here because it's we control those nodes. But still, it's a bit of a problem. It's funny. We're loading from this. Very, very, very interesting. So, color tokens actually are tokens which are IOTAs with assigned color codes to the to it. And you can use all kinds, you can attach to the color, to the code of the color, you can attach all kind of semantics, meaning, and this semantics may be easily interpreted by the smart contracts, because IOTA smart contracts, they can move anything what is on the ledger, meaning that IOTAs, be it IOTAs, be it as color tokens or whatever. Just like in this fair auction example, when this auction will be over, it will be sold for some guy, nobody will bid it more. Currently, winning bid is 2 IOTAs for this token. And if nothing will change, all these, the token will be sent to this guy, to this address. So smart contracts are able to manipulate tokens. I mean, color tokens or IOTAs in whatever way they want. So now let's go next. Okay, so how does it look like on the Tangle? If we have a Tangle, yeah, I am hopefully. If you have Tangle, so you have many smart contracts. Each of them is instance. By the way, I didn't mention what is important concept of it. Of course, we're talking about the programs. So each address, behind the address, there is a program. The program, it's a long story. The programs can be anything. Currently, it's a hard-coded. In the future, it will be WebAssembly programs, which will be run by the virtual machine. But what is important here, that actually smart contract knows its program by the hash of its binary. In this case, this one, yeah. And that's why once the smart contract is immutable, so the program is immutable, and it's locked into the smart contract. It can be downloaded from anywhere you want, but what I want, why I came back to this step. So actually, it's because we wanted to say that programs, we can imagine the Tangle has many programs on Tangle, which each behind the address, they are represented by the chain of state transactions with each transactions are moving the colored token along the chain. So this is a concept here. Show that it's each smart contract is a colored token, and the chain represents mutations or updates of the state. So you can imagine smart contracts as one smart contract as a blockchain, and many smart contracts are many blockchains on the Tangle. How do you like it? So it's smart contracts. They contain their data on the Tangle, but we're talking about the automation. So it means that automation means that Tangle should provide some services to us. How it looks like? We want to access some function for smart contract. So what we do? What do? We send a request to that smart contract. So request, what is request? We're asking for a function which is request code, a function name. You can imagine it's a function name. Target smart contract address, the instance of the smart contract, and then we attach parameters, and we can also attach time lock. The time locks a little bit later, but anyway, what we do have here that each request is a value transaction. Each is a value transaction means that we always send some IOTAs or colored tokens with it. It's impossible to have zero value transaction on value Tangle, at least at the moment, but I think it's pretty much natural. And what we have here, requests are some kind of packages. We're sending to smart contracts or between smart contracts, because each smart contract can also send this message request to another smart contract to its address, which contains tokens, funds, funds, and it contains data of that request. Or you may see that it's metadata and instructions what to do with the funds which are sent. Yeah, and this request result, it when you send it, in the end, it ends up of the settlement of this request in the smart contract state as a state change according to the algorithm, to the program. What is important here is that we guarantee in the protocol that all requests will be processed once, and independently of how the actually Tangle, I mean, nodes can be coming up, down, and so on. But once, why we guarantee? Because actually this is a on Tangle messaging, meaning that each request is a transaction which should be confirmed. Once it is confirmed, it will be settled in the smart contract, provided, of course, if the all possible nodes of the smart contracts won't be stopped. Theoretically, it can happen, practically not very much so. So we guarantee that the backlog will be processed and each of them will be processed once. Now, how we do it? In short, it's also a token magic behind. It means that each request means one token creates new color, very transient, very short-living color, and this is an indicator of request that it starts living, active, and whenever it settles in the state, the color is destroyed and it disappears from the background. This is a pretty much very efficient, very reliable scheme of handling the backlog. Now I will do the following. I want to send a request, and of course I have to ask and pray to demo gods to the contract, which is called Donate with Feedback. So actually, it's already working for more than a week. What it does, what does it do? We are sending IOTAs to the donation address, which is donation address is the address of this smart contract, and we send tokens with some text, which is comment or feedback. Yeah. So what we do? First of all, here I have some demo wallet, and I do wallet balance. I just show from the Goshimer how many IOTAs do I have. By the way, this balance is 1,246 IOTAs, and also I have 3 other tokens here with other colors. But I'm sending IOTA. Now I'm sending to this smart contract W wallet, donate with feedback, donate request. Yeah. Yes, donate amount, donate. Let's say how many? Okay, we want to be the biggest one, so we have 150 donate, and we send demo donation IOTA English network. This one, yeah, here, and we send it. So what's going on here? We can see here it's waiting for something. Actually, the wallet sending transaction to the Goshimer should confirm that transaction. Then the Wasp nodes, the committee nodes, pick that request, and they are putting the all of it. Yeah, here is appeared. So these are two consequent. Yeah, these are consequent two confirmations of two transactions. And actually, you can see that it's the request transaction ID is this one. Yeah, here. And here also request ID, this one here. And now we have the largest donation so far, 150 IOTAs. It's pretty hello world level of the application. However, it has one interesting thing. First of all these donations, many people are saying, hello, I'm the one with the largest donation. Not anymore. They are immutable. They are immutable in the smart contract ledger. Once the smart contract is running and Tangle is running, it is immutable. This is an example how many data we can put. We can put practically endless logs, amounts of data, of all kinds of data. You can imagine the sensor data for many years or something like into the smart contract immutably. Because it is off Tangle, actually, all this data. I will explain how it works in detail next. So, state of the smart contract, how we do this. It's actually was developed exactly with this type of use cases in mind. When we want to have really immutable databases or historical databases of all kind of data, but actually we don't want very much to put them all into the Tangle, because what for? I mean, for many reasons, for privacy reasons, by the way, for the reasons of the GDPR and so on. If you put something in the Tangle is global, so the data is leaving EU. It violates data sovereignty requirements, right? So we can think about the solution like we put often to Wasp nodes, and we know that those Wasp nodes are running in some EU, for example, or in the country, and the data is there. The sensor data, the private person's data, the any data. Yeah? But what we do is that we anchor all these data, which is kept outside of the Tangle in the Wasp nodes, in the distributed database of Wasp nodes. We anchor them or lock them or whatever with their hashes in the Tangle, and it forms the non-forkable chain of anchor transactions due to the smart contract token, non-fungible, because you cannot fork it. So actually, for the Tangle, it's pretty much how to say, it's just a sequence of transactions with hashes and nothing more. While the whole actually practically limited, but huge amounts of data, which is locked by these transactions, by these anchors on the Tangle, is outside of the Tangle, and it could be located hidden from the public view or open, whatever. It's up to you. And also, it could be a good solution for the GDPR requirements. This is in short, this is a tamper-proof and immutable, but off Tangle on Wasp nodes, while on Tangle is on Goshimer would be. Yeah? And actually, on Goshimer, it's all token logic, all moving tokens to addresses, and so on, and the locking of the off Tangle data. This is a little bit of the complicated picture of that. I don't know. Put it here, but the very idea is that we have on Tangle chain of starting from the origin transaction, all the growing chain of the state updates, and you have the so-called batches of blocks, blockchain, and then almost all the sequence of batches in the off Tangle in the Wasp node. And they are all locked by the hashes of them, because it contains hash of the state of the smart contract, each of those transactions. So, so to finish, okay, I'm finishing actually, but just few words about the. I didn't plan too much to talk about the virtual machine, but I think it's worth mentioning what we do with that. It's not now currently in the Wasp node in this version, but will soon be there. So what we do with the programming environment? So we use WebAssembly as binary format for VM executable, meaning that we run programs, external programs of smart contract programs. We run as WebAssembly, and theoretically it can be any language as a source for it, whatever is compilable to the WebAssembly. But actually, also taking the examples from many other reasons are. Why it is Rust as the main source for smart contracts? Mostly because Rust is very good at small binaries, small WebAssembly binaries, and it's good in many things. It's very robust and deterministic language. So the programming environment for smart contracts will be Rust, at least main of it, because in general, the whole structure of the VM, what we call the VM abstraction, it's largely agnostic about even the WebAssembly or not WebAssembly, and of course it is very agnostic about what the source language is, because you take a Rust program, you call some get, something you want to get from the state, to compile it to the web binary, and now you lose any link with the Rust as such, and it's loaded into the VM and the processor. It has entry point, and then the consensus of the Wasp nodes is calling this program on the virtual machine and giving them as a parameter the so-called sandbox. So there's some limited interface for them to access the state. So basically, it's pretty much abstract and agnostic about the specific types of binaries and so on scheme. However, we will use WebAssembly as it and the as a binary format, and the programming environment, main programming environment, will be in Rust. If you will want to develop something else, you are very welcome. So I'm finishing. But just I didn't talk. This is meant to be pretty much technical talk, because like I said, what to talk about them? About smart contract, they all do the same. They are just distributed programs. That's it, like that. But when you want to understand what's the difference between all kinds of them, you go technical. So that's why. But basically, if to wrap up it all, what we do is functionally equivalent to Ethereum or something, except maybe that we have UTXO, not account-based smart contract, which I think is better. The difference between the other smart contracts is feeless nature, because smart contracts, for example, here, if you look into the smart contract details and you look here, minimum node reward at the moment is 0. Nobody is charging anything. You can put it more. You can put something, and then you will be obliged to send some IOTAs with a request for it to be processed. But anyway, we have feeless nature. We have level 2 design, and we have static committees. It's a lot of different trade-offs, keeping in mind the low cost and scalability of the architecture. And we will, talking about the use case perspective, of course, we are always talking about the markets, open markets for committees, about staking, about all that stuff. Talking about the use cases, you just look into the open world of the smart contracts and pick whatever you want. I mean, whatever you see here as use cases, it's applicable to here. Of course, you have to take in mind the specific nature of these committees, static committees. So you have to take care about the trust to the committee, to staking and to other things. It's not in the protocol at the moment, but in general, if you're talking, can you do something? Yes, answer is yes. And we believe we can do more, because you cannot manipulate these small amounts like 1 IOTA in smart contracts on many ledgers, because they have fees. And here you can do it. So, and of course, the 2-layer architecture gives you tools to solve these problems of the GDPR data sovereignty, like I explained. Thank you. Questions will follow. By the way, I will immediately show you. We'll open our repository, and just a moment, Daniel.
Okay. Sorry.
If I could, just a moment. This is a repository, and there are among code, of course, but there are several articles which were written just to explain how it works. So these are main concepts with Donate with feedback. You can read it and you go through all elements of it, explaining. You even can deploy your smart contract instance of it, and so on, including including the code of the hard-coded smart contracts too. So here I finish, and thank you again.
Okay. Thanks a lot, Evaldas. That was great. I'm pretty sure that a lot of us will watch this talk again because there were a lot of technical details and it's going to be of huge value. So we do have some questions from the chat. So because we usually try to keep it under 1 hour, let's go through the questions. So the first one is, you can read the questions, Evaldas, right? I'm gonna read.
Yes, I can read. I can read them.
So Ben Royce is asking, what are some examples of adjusting extensions, maturation, etc., to the development of the underlying ledger? Mana, for example. I assume it requires some adjustment.
Yes. First of all, we have, with smart contracts, we have the base layer, the underlying layer of its moving target a little bit. So we always has adjusting. Now, currently, guys are developing new version, and we will have to adjust, and we will take advantages of that. Also, we're thinking about the chrysalis ledger too. And yes, that's examples, and we are not should not take it like a very finished product. Is very far from that. We have invested into the make it stable, make it secure, and many aspects. So that's what I mean by this.
Yep. Yeah, it's moving, and it makes a lot of sense to be in development together with what's going to happen on Chrysalis Phase 2 and also with the Core side, because at the end of the day, this is something that we'll have to run on the Core, on the new IOTA 2 version. So even though we are all waiting for it, it makes sense to have like this parallel and paired development between what you guys are doing and the status of Chrysalis and Core side as well.
By the way, sorry, this was also in this question, Mana, for example. Actually, I don't expect too much adjustment Mana with regards to Mana. I mean, Mana is mainly related to the congestion control, rate control, everything which is not exactly the function for the smart contract, but we will see. I'm not sure. I didn't see it yet.
Yeah, it's related to how to secure the consensus. But well, you guys are running as a level 2 solution over the Tango, so even though it is not directly involved on smart contracts, it's working down there. Okay, so let's have another one. This one is from Gabriela Jara. So Gabi is asking, how will I find members for my smart contract to run in practice, and how exactly will we agree on the fees? Will there be a marketplace or a matchmaking function?
Yeah, this is a good question, and I actually anticipated that a little bit. The all committee related stuff, actually committees is kind of consensuses between themselves. So fees must also be, someone has to decide on the fees. So you must run some kind of voting or consensus to adjust to those fees and many other things. So we left it outside of the current protocol. It's actually on top. When you select a committee, you can apply all kind of protocols to that too, and they should agree then on fees, because it's the nature of the fees. I mean, if you set the fee, minimum fee, you have to agree with everyone.
Yep. Okay, let's go to another one. I think this is the last one, actually. This is from Fernando Boyero, and he's asking, what will happen if a couple of assembly members, let's say the 50%, stop running the smart contract? Will it stop or continue to run? can I, as a smart contract owner, replace assembly members?
Yeah. If you stop more than you need a quorum to run it, right?
Yeah.
So if you run below the quorum, it will stop running. Stop reacting to the request. By the way, requests won't disappear from the tangle because they are untangled. So if then you later, when you start again, you come back to the quorum, it will run again. Now, this is first. And so when you formulate the question like this about my smart contract running by someone else, not you running the smart contract. For example, I'm a corporation. I'm running the smart contract in my department. This is possible. I am part of the consortium of big players, and we together are running the distributed marketplace for whatever. Yeah. So I should not stop running. I have a commitment to it. So coming back, if the situation is like me and someone is running for me, you want to have agreements with them. You can, for example, require a stake and some agreement that you will fine it or slash it or so whatever, punish it for not being committing to the agreement. So that's how I imagine. But you see, my answer is already proposes many solutions for different situations. That's why it's open. It's use case specific.
Great. Okay, Evaldas. So right now we hit the hour. So I think that's it. I really want to thank you for taking the time to take us through all this work you guys are doing. This is amazing work, and I'm pretty sure that we will have amazing IOTA smart contracts in the future. So again, thanks a lot for being part again of the IEN Talks, and also thanks a lot to everyone who tuned in and did some questions for Evaldas. So thanks and bye, guys. See you on the next IEN Talk.
Thank you very much, Daniel, and goodbye, everyone.
Bye.